Hi, future doctors. Welcome to the next class. We were discussing circular motion. In this class, we will discuss relation between linear velocity, relation between linear velocity and angular velocity. If any object is moving in circular path of radius r, now radius vector is rotating from A to B. How much angle it is rotating means theta. A to B it is taking theta. Now, what is its velocity? So, velocity we will take this distance by time. Its speed is constant, but its velocity will be changing according to its direction is going to change at each and every point. Correct? Already I said this. Tangent gives the direction of the velocity. Therefore, they will write speed here, distance by arc length by time. Simply we are doing because we don't want derivation. We want only final. Now, what is the relation between theta and arc length? In basics, we have given arc length L is equal to. In distance displacement case also we give. So what is the arc length? L is equal to theta r. Substitute. So V is equal to theta r by t. So what is theta by t? We came to know. Angular velocity is theta. Therefore, V is equal to r omega. So in vector notation, they will write V bar is equal to r bar cross omega bar. Now, what is its direction? Omega direction. What is the omega direction means? Angular velocity direction will be always along the axis, depending on its axis of means rotation, anti-clockwise or clockwise. By using right hand our thumb rule, you can take clockwise or anti-clockwise. We are going to get right hand thumb in which direction angular velocity will be in that direction. This is linear velocity, angular velocity relation. Next, a linear acceleration, angular acceleration. How it will be coming means, just this equation you have to divide with time on both sides. The velocity by time, angular velocity. This is linear velocity. This is angular velocity. A is equal to r alpha. This one only they will say tangential acceleration. In which direction this tangential acceleration will be present? If any object is moving in circular path, we will have total two circular paths. One is non-uniform circular path and uniform circular path. So what is the difference between non-uniform, uniform? Very important and confusing. So whether uniform or non-uniform, both are going to be circular motions. So to move any object in circular path, which force is going to be acting means centripetal force is going to act. So at each and every point, centripetal force will act towards the center. Therefore, centripetal force is acting towards the center. This is the cause to move object in circular path. If centripetal force is not there, object will not move in circular path. This is the direction of velocity at this point. Now, what is the direction of tangential acceleration means? In which direction velocity will be there? In that direction, tangential acceleration will be there. So, here tangential acceleration means velocity also will be in this case. But when means if speed means velocity is going to increase. If velocity increases, tangential acceleration will be in the same direction. If velocity decreases, then tangential direction will be in opposite direction. So tangential direction will be again when the name on it is there, tangent gives the tangential direction. Now towards center, centripetal acceleration, which whenever force is acting, so say acceleration is going to be there. So this is called centripetal acceleration. Centripetal acceleration always acts towards the center. Therefore, in uniform or non-uniform, which is common means centripetal force is common. Therefore, centripetal acceleration is common for both uniform non-uniform. So if it is having only uniform circular motion means only centripetal acceleration will be active. If it is non-uniform means both centripetal acceleration and if object is moving anti-clockwise, so tangential acceleration if velocity increases. Because in non-uniform means its value is going to be increasing. Uniform means it is constant, therefore no tangential acceleration. Next, if velocity decreases, what is the direction of tangential acceleration? So centripetal acceleration always towards center. If velocity decreases, then tangential acceleration will be opposite to velocity. If velocity decreases, here velocity increases in this direction. So, however, whether increasing or decreasing, the angle between tangential and centripetal acceleration will be 90 degrees. Now, what is the net acceleration in this? Net acceleration is going to be A is equal to root of AC square plus AT square. So here what is the net acceleration means? Only centripetal acceleration. Correct? This is AC square plus AT square. Here also same. This is AC square plus AT. This is the net acceleration. Root of AC square plus AT square. But what is the difference means? Resultant angle, whenever it is going to make, resultant angle is going to be different. See here, this is going to make theta angle. So from this, tan theta is equal to opposite side by adjacent side. Opposite side means tangential acceleration. AT by AC. So this theta is making how much angle with centripetal acceleration. Here also same. Theta is making how much angle. But sometimes this theta with velocity they will ask. With velocity, whenever they're asking, velocity will be in upward direction. So what is the resultant angle means? 90 minus theta. So this net acceleration is making how much angle with velocity means 90 minus theta. Here see, net acceleration is making how much angle with velocity means this is going to be 90 plus theta. Correct? So this one you have to take care very clearly. So blindly you can follow in non-uniform circular motion, net acceleration AC square plus AT square. Two will be present, centripetal, tangential. In uniform, only one acceleration, centripetal acceleration. Its direction will be changing from point to point because it is a vector quantity. Correct? Now, what is the centripetal acceleration formula? What is centripetal force formula? mv square by r, mr omega square, mv omega. So, how you will get means in place of v, we have to write r omega. So, Fc is equal to m by r omega whole square. You will get this. So, total three formulas for centripetal force. Therefore, three formulas for centripetal acceleration. AC is equal to v square by r omega square, v omega. This is called centripetal acceleration equation. So this is uniform, non-uniform resultant acceleration, and which accelerations are going to be taking place in both uniform, non-uniform. If it is circular means definitely centripetal force should act, therefore in both centripetal acceleration is common. But if it is non-uniform means tangential acceleration also will be taking place. Okay, so practice these equations with resultant angle, net acceleration, then definitely you will get problems on this. Thank you.